9 marks. Okay, now let's move to the question 7. Question 7 says that figure 3 shows a sketch of the part of the curve C1. Given that C1 has equation y equals f of x, where f of x is a cubic function. Okay, this f of x here, this C1, my f of x is a cubic function. Okay, and you know cubic functions appears like that, x cube thing, right? We don't know the other details, so let's just see what is it. Second thing is it touches the x-axis at the origin and cuts the x-axis at x is equals to 4. Okay, it is touching the x-axis at origin, like it's taking a bounce at origin and then cutting the x-axis at 4. Okay, it bounces at 0, which means the multiplicity power is gonna be 2 here. Okay, like in the form of factors I will be writing x minus 0, so the power will be 2 here. Okay, when the curve bounces through the x-axis, so we take the even multiplicity, the power should be even. Since we know it's a cubic function, so the maximum power for this function is gonna be cube, and we got, okay, we can't have a power more than 4 here. We can't have an even power as 4, because that will then become a quartic function, which we don't need, right? So, and it is cutting at x is equals to 4, so the factors will be x minus 0 to the power of 2, because it is bouncing at 0, and x minus 4. Okay, this is plus 4. When you move it to the other side, like x is equals to 4, now when you move it to the other side, that becomes x minus 4. Okay, in order to write the function, yeah, passes through the point, this curve is passing through the point 10 and 120. Okay, find the f of x. So first of all, let me write the f of x. Part A, we should know that f of x is a cubic curve, so it should look like this: a bracket x minus b, x minus c, x minus d. Okay, so this is the standard function for a cubic one. So we don't know what is a, but we know the curve is bouncing at 0. The curve is bouncing at 0, so we are gonna write it 2 times: x is equals to 0, x is equals to 0. Make zeros to the other side, that becomes x minus 0, b is 0, x minus 0, c is also 0, and the other, since x is crossing at 4, so x is equals to 4, that becomes x minus 4 here. Okay, x minus 4, right? So here is your f of x. Or you can write a bracket x minus 0 becomes x times x, that is x square. Okay, and then x minus 4, that is your f of x. But now still we have to find the value of a, which is pending. In the third point, they are giving you that the curve passes through the 10, 120 point. Okay, if the curve passes through the point, it means you can insert that point into the equation of the curve. Okay, so yeah, we're now gonna replace f of x with 120. A comes as it is, and replace x with 10. Okay, because we are inserting that point into the function. So 10 squared, 10 minus 4, so 120 is equals to a. 10 squared will be 100 times 10 minus 4 is 6. Okay, so 120 is equals to a 600. 6 times 100 will be 600. We divide both sides, or you can write it as 600a. You divide both sides by 600, so you will get the a value, and upon simplifying it you will get 12 5 times 1 over 5. Okay, or 0.2. a is 0.2. Okay, now we'll just replace a value 0.2 in this. We already know b, c, d values. I'll replace a values in this thing. My f of x will be 0.2 x, this x squared times x minus 4. Okay, so x squared times x minus 4. So this is the simplified f of x function you have. Okay, you were given a point, you substituted that point. You were given the multiplicities, like the x-intercepts, so we substituted those x-intercepts in the function, in the standard function, and you got the curve equation. Okay, curve function, yeah, the function for the curve. Okay, part B. The curve C2 has equation y equals 1.2x times 8 minus x. Now this is another curve C2 whose equation is y equals 1.2x times 8 minus x. On the following page there is a copy of the figure 3 diagram called the diagram 1. Okay, on the diagram 1 sketch the curve of the C2. So yeah, here our f of x is already plotted for curve 1. Now we have to plot C2 function on it. Okay, let's see how the C2 looks like. So this is the part B. C2, this is our C2 curve, y equals 1.2x times 8 minus x. Y equals 1.2x times 8 minus x. You know, when you will expand this thing you will get a quadratic function, but we will not do that because we can simply to find, okay, and to plot the quadratic function you need three things. You need x-intercepts and you need y-intercepts, you need a vertex. Okay, since the vertex is not specified here, we are not given any points here, so vertex won't be needed, but still we can at least have an idea. To find the x-intercepts, I replace y equals to 0. So you put both of the factors equals to 0 one by one, yeah, and you get x is equals to 0 from the first one and x is equals to 8 from the second one. Okay, so x is equals to 0 is my first point and x is equals to 8. Okay, we already know this point is 4 now. From the above curve we know this is 4, so obviously from 0 to 4, so 8 will lie somewhere here then. Yeah, 8 will lie somewhere here. Okay, equidistant from 4, so that is 8. Okay, alright, so these are the x-intercept. Okay, another thing, when you will expand this thing you will see you are getting a negative x square coefficient. Like when you will multiply 1.2x times negative x, you will get negative 1.2x square. Okay, so your a value is negative 1.2, which is negative, and you know that when a is negative, the parabola, the curve, okay, for quadratic it either it is gonna be an open up parabola or open down parabola, but when your a is negative you get open down parabola, and when a is positive you get open up parabola. Okay, but right now our a is negative, so we will get an open down parabola. Okay, so we already know the x-intercepts, and you know the vertex is gonna be the middle. We are not sure about the y point, but the vertex is gonna be the middle of the x-intercepts. Okay, so the middle of the x-intercepts is gonna be 4, as you can see here 0 and 8 is 4, so the parabola will look something like that. And also the y-intercept, what do you do for the y-intercept? For y-intercept you put x is equals to 0, so try to replace x 0 in it, you will get your y as 0. Okay, so my y-intercept is also 0. Let me write it here. Your x-intercepts are x is equals to 0 and x is equals to 8. Y-intercept, for y-intercept you put x is equals to 0, so you replace x 0 in the equation and you got y-intercept as 0. Okay, and the vertex coordinate, you already got the x coordinate now, which is going to be the middle of the two x-intercepts. Okay, which is 4. For the vertex, you know that x coordinate is 4, but what is going to be the y? So you just replace x is equals to 4 into the y equation. Okay, and you will get whatever thing, but we are not really concerned with that. This is how the parabola will look like then. Okay, because nothing is specified, whatever thing you will get here, it is going to be 19 point something though, but you don't know where 19 lies, either here or here, you don't know that. Okay, so that's why vertex is not needed. You just wanted the middle point for x, we got that. Okay, which is 4. So this is the graph for the C2 curve. Okay, now part C, use algebra to find the coordinates of the point where curve 1 and curve 2 intersect. So we have to find the point of intersection for the curve 1 and curve 2. Okay, as you know, to find the point of intersection we put the y's of both of the curves equal to each other. So yeah, that is gonna be your part C now. You put the y's of both of the curves equal to each other. So equation for curve 1 is, where is the equation for the curve 1? Okay, that is 0.2 x square times x minus 4. Okay, 0.2 x square times x minus 4. I'm gonna keep it equals to the equation of curve 2. Equation of curve 2 is 1.2x times 8 minus 6. Okay, so that is 1.2x times 8 minus x. Okay, now we're just gonna simplify it. So first, yeah, you're seeing here you have x square and here you have x, right? So you can just take the x out from both of them and cancel it. Basically that x doesn't get cancelled, you just keep it equals to 0. Okay, you cancel out one x and that x will be 0, will give you the 0 root. So the remaining one will be 0.2x times x minus 4 equals to 1.2 times 8 minus x. You never cut the x's like that. Cutting the x means that x is giving you the 0 value. Okay, one of the root is x is equals to 0, you can skip that. Okay, so one of the x we already got, that is 0. Now we can expand, so we'll get 0.2 x square minus 0.2 times 4. Okay, I don't know, 0.2 times 4 will be 0.8. okay, is an x, I'll just put the x here, equals to 1.2 times 8. 1.2 times 8 will be 9.6, minus 1.2 times x will be 1.2x. okay, now we'll bring down the whole equation to one side, that becomes 0.2 x square minus 0.8x. This minus 1.2x will become plus 1.2x, and minus 9.6 equals to 0. okay, that becomes 0.2 x square and minus 0.8 plus 1.2 will be 0.4 plus 0.4 x minus 9.6 equals to 0. Okay, it's a quadratic, we will try to simplify it. As you can see, this is 0.2, this is 0.4 and 9.6. I believe the whole will be divided by 0.2. yeah, let's try dividing whole equation by 0.2 in order to simplify it. So this 0.0.2 will be gone, so x squared plus 0.4 divided by 0.2 will be 2. okay, so you got 2x here minus 9.6 divided by 0.2 is 48. okay, is equals to 0 by something will be 0. Now it's a quadratic, we will factorize it, or you, if you don't know, if you get stuck at factorization, you can use a quadratic formula. okay, so x square coefficient is 1, you times 1 with the last number, which is negative 48. So two numbers that multiplies to get negative 48 and adds up to the middle term, which is 2, are 8 and 6. okay, 8 times 6, but since we need plus 2 and negative 48, so I'll put the minus 56. okay, now 8 times negative 6 will get you negative 48, and 8 plus minus 6 will get you plus 2. okay, we're getting the middle term. So after getting the factors, how do I write it? This x square, I'll expand it with two brackets, and then I'll just put those two factors here, which is plus 8 and minus 6. okay, simplifying it, you will get x is equals to minus 8 and x is equals to plus 6. okay, so these are the two x values. Let's see if they are looking for the points. Use algebra to find the coordinates of the point where C1 and C2 intersect. Yes, we need the whole coordinates. So you should know that these are the 2 points we have got. One of the point is minus 8 and we'll get the y, and the other point is 6 and we'll get the y. How do we get the y's for both of them? We will just insert these values of x into the original curve. You can use any of the curve here. okay, either use this function or the quadratic function, because they both are intersecting, so you can use any of the curve now. okay, I'm gonna use y is equals to 1.2x times 8 minus x. okay, so one of your x value was negative 8, you will replace x with negative 8 here, So 8 minus 8, that gives you 8 8 16, and times minus 8 times 1.2. okay, I'll just put it in the calculator. Times negative 8 times 16, that is negative 153.6. okay, alright, so when x is negative 8, y is negative 153.6. so this is one of the point, right? When x is negative 8, y is negative 153.6, negative 153.6. okay, when x is 6, what is gonna be your y? We'll just replace it in this point again. Let me get some space and erase it. When x is 6 now, so you replace x with 6, 8 minus 6, which will get you 1.2 times 6 times, okay, 8 minus 6 will be 2, so that gets you 14.4. okay, 14.4. when x is 6, y is 14.4. so these are the 2 points of intersection where the 2 curves intersect each other. okay, so that was your question number 7. Here you can see it was a bit lengthy too.